When we see on the project background, so this project was motivated by the need of a device that would generate electricity from the human motion, especially footsteps. And this system also can be proved effectively in crowded places such as railway stations, shopping malls, and the places where a lot of people come. And this is because we can use it as a source to generate the renewable power free of charge or free of cost. So when we see on the problem for the existing product, so the first thing is a massive amount of energy loss during the conversion process from the kinetic energy to electrical energy due to lack of effectiveness on gear mechanism. While we see on the second effects, which will be on usage of sensor, piezo sensor, so which can detect the pressure applied and convert to electric energy. This development improve the effectiveness of product in addition to increase the manufacturing cost and make the product cost increase and expensive. So the third one is the existing product usually lacks sensitivity towards the force applied by the human footstep because of the arrangement of plate rack and product mechanism. We focus on the project objective. So the objective will be on produce user towards the advantage of renewable energies, and the second thing is create a device that can harness renewable energy from human footsteps, and the third thing is study on the problem on designing footstep electrical generator. So when we see the scope of the project, so the first scope is metal instruments is used in this project, which consists of gear, motor, shaft, pinions, spring, as well as electrical equipments to convert the kinetic energy created into the electrical energy that can power up the light or any other small voltage devices. So the second thing is the multiple design is created to study on the problem faced to develop a footstep electrical generator from multiple design. And the third thing is welding process is essential to fabricate footstep electrical generator, and a proper circuit is connected to the motor that is connected to the gear mechanism. And fourth thing is the product testing is by the stepping process to inspect any error that may exist within the product and any power can be generated by the product. So while we're referring to the organization chart, so each of us have our own position, which will be starting from the project manager and followed by senior engineer, quality control engineer, and two project engineers. So when we see on the project significance, so the first thing is renewable source of energy. So using the renewable source of energy which created by human step is the most convenient way to produce and use electric power during the emergency situation. So it will be a better alternative for using the current source from different places. And the second thing is cost efficiency. So using conventional energy source will cost some penny as well. We have to pay for the power source according to the voltage used. But by using the footstep generator, electrical generator, the amount of voltage will be based on the footsteps that collected by the generator. The device can be placed anywhere and any places, such as I mentioned before, the crowded places. Well, when we see on the team formation, so we choose mechanical head as our group name because it's a variety of meanings, and we try to connect with our subject, which is integrated engineering design. And our team also we have our own logo, which indicates that we are engineering students. And in our logo, there's a gear, so the gear will be on red color. So red color is associated with passion, strength, and determinations. So we choose this color to our logo because we believe that the meaning behind them will assist in achieving our goals while doing our project. Okay, so design process model. So this design process model consists of a conceptual design, embodiment design, detailed design are the three stages of a design process. So when we see on the overall design process, it consists of defining the problem and then followed by a gather informations, concept generations, evaluation of process, or evaluation of concepts and product architecturings, configuration designs, parametric designs, and lastly will be on detailed design. Okay, lastly we see on the general task delegations. So delegations gives the subjects more decision making power, and our group made the decision to divide up the tasks among the group members to ensure that project can be completed within the given time frame. So all the group members will make the responsible for the contribution to this project by fulfilling their specific tasks and increasing the productivity. So this approach is derived after discussion of every group member. So the division of the work will be equally separated among the group members.
Assalamualaikum. My name is Muhammad Aminuddin bin Muhammad Nazri. I would like to present on Chapter 2. First, identification of market needs, market survey, and customer certification. Since it's the simplest way to approach individual and there has been little movement, we choose to use a questionnaire using Google Form to collect information from people for this project. This survey, which was conducted using a questionnaire and distributed to the target audience of student, technician, and engineer, was carried. First point is data analysis for part A, respondent background. Okay, firstly, gender. There are 60.7% of a respondent is male and 39% is female. Second, race. There are 54% of Malay, 23% of Chinese, 70% is Indian, and others is 40%. Third, age. There are 80, 85, 65% of 23 until 27 years old. Then next, 21% of a respondent is 80 and until 22 years old, and others is 28 above. Fourth, profession. The majority of respondent is student, which is 90%, and there are a few of technician and engineer. Second point is data analysis for part B, which is about respondent knowledge on Footstep Electric generator. There are 78% of respondent answer yes for question, do you believe in renewable energy? And others 20% say no. Next, have you heard about Footstep Electric power generation? 57% of respondents answer yes and others answer no. Next question is, do you prefer a bright or dark environment? About 85% of respondents answer yes, answer bright, and others answer dark. Next question is, how safe is your surrounding? The questionnaire is in scale. Scale 1 is so bad, skill 2 is bad, skill 3 is intermediate, skill 4 is good, and skill 5 is so good. Okay, based on this question, 60% of a respondent give 5 skill. Then 27 of a respondent give 4 skill, 34 of a respondent give intermediate skill, and 30% of respondents give 2 scale, and the lowest is 8% of a respondent. Okay, next, the question is, Do you think this product will be helpful? Okay, there are 40% of respondents answer the 5 scale, which is so far so good. Okay, the next point is data analysis for part C. It is about the respondent opinion about characteristic of footstep electric generator. First question is easy to maintain, which is almost of the respondent give 5 scale about this question. Next, durable. 45% of the respondent give 5 scale, while 29% of a respondent give 3 scale. Next, affordable. Almost of the respondent give 5 skill, which is 45% of the respondent give 5 skill for this question. Okay, next question is rigidity. There are majority of a respondent give skill 5, which is 50% of a respondent give 5 skill. Next, rust roof. 27 of a respondent, which is 40% of a respondent, give 5 skill for this question. And lastly, compatibility. There are 45% of the respondent give 5 skill for this question. It shows that between this seed question, all the respondent believe that this product will give a good performance. Next point is data analysis for section 3. It is about respondent opinion and suggestion on footstep electric generator. First question is, how do you think a footstep electric power generation can be applied based on your application? Almost of the respondent give the suggestion on every step can make charge up small device, and the electric power can generate emergency can make an emergency power. Next question is, what improvement that you think can be made for this project? There are a few exponents say make it is in mass production and can create in a good condition and good shape.
Assalamualaikum, my name is Sublan Iskandar bin Muhammad Razali. I'm going to tell about chapter 3, conceptual design. This phase will be carried out by investigating the component that we will working on the product, the understand of the product works, and the component is essential on this part. The importance of the conceptual design in creating a great product cannot be overstated. Engineers and designers work together to comprehend any difficulties and find solutions throughout the conceptual design phase of development. Next is for the component of the footstep electric generator, which is base, which is consists for component, base, body frame, generator, and inverter. For the base part is the sub-component is spring, and the body frame sub-component is right pinion and gear and shaft. So generator which sub-component is a battery and inverter sub-component is transformers. For the base uh, for the base analysis is a human stepping on the base and force is applied, and the spring is being compressed and the base moved down vertically. And for the body frame is the vertical motion and a pinion gear, and the gear rotate the shaft. Generator attach result to the sinusoidal waveform to obtain the wave voltage and power stored directly in the battery. The battery convert to DC voltage to AC voltage. The converter AC voltage is stepped up to AC to 140 volt by transformers. So for the standard function block is to describe the flow of the footstep electric generator. Based on the block diagram, human step on the plate, so the weight of the person that step on the plate is applied by force. So the plate is moving by rack and the pinion. Turf energy is generated by motor through the battery. And so kinetic energy from the gear is transferred to 12 DC motors. From this point, electric energy from the battery is passed to a inverter, and the electrical energy from the inverter passed to the transformer, so that electric energy from the transformer passed to the load, which is uh, light up some our mechanical component. Lastly, for this chapter, it's about the product sketch. For the left is the first first sketch, which consists of different type of plate and different type of mechanism. In the middle is the different type of plate and different type of mechanism that we use. And lastly, for the sketch number 3 is the concept that we use. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakimi and I will present to you about chapter 5 for design analysis. So for assembly drawing, this is our assembly drawing for footstep electric generator, which consists of housing, top plate and motor, shaft, bearing, spring and also battery. So from this drawing we able to do each part accurate to original dimension and assemble it according to our design. After we do the assembly part and drawing for each part, we then do separate testing for analysis simulation. For our project, the only part which we use for analysis is the housing and the shaft. The main housing consists of ASI 316 stainless steel sheet with tensile strength of 580 and yield strength of 172. The density of our housing is 0.29 pound per cubic inch, mass with 9.70 pound and volume with 33.56 cubic inches. For our housing analysis, static analysis on the stress von Mises stress, we are able to obtain the value and the FEM model by using solid modeling software. So the highest stress concentration is 1.962, and from the diagram we see that there are bending happen at the side of the panel, which result from multiple force and major force supply. And for this value, we obtain equivalent strain, which is 4.58, value, and we as the force increase, there may be a bending occur at the top of the plate here, as we see in the figure. For this resultant displacement, we obtain the highest value of 4.155 at the red area, which apply that major displacement might be occur at the area. So our next part, which stress is concentrated, is in the main shaft. From here we can see that the von Mises stress value is 2.03, and there will be bending occur at the main shaft if the load is exceed from certain value. For the shaft, the equivalent strain is 2.55, and we can see that the bending is probably will occur from the figure shown below. For the last picture here is the displacement that probably occur at the main shaft, and the bending is slightly more compared to the von Mises stress, which is 2.05. This resulting that if the force exceed the limit value, bending will occur and probably dismantle the product.
For Chapter 7, Sustainability and Environmental Consideration and Engineering Design. For economy, reduce cost consumption for electric bill. Example, shopping mall can reduce electricity bill by installing Footstep power generator. It's affordable because we use low cost material and recyclable material, and it's low maintenance because it use long lasting material and use the easy to use and install. 4. Eliminate the chances of electricity cable stealing that usually occur in other products as our product installed underneath the surface, and encourage people to use renewable energy, thus increasing the demand of product and increase economic growth. For social, we use less energy to install without burdening bodies and easy to maintain since each part is easy to obtain and operate. It's an eco-friendly product since the product is installed underground work passage and there is no weight limit to put in this product, thus children and adults can produce electricity with their own weight, and installation can be progressed at crowded area which can produce more efficiency of power generated. For environmental sustainability, we can save up installation space rather than any renewable energy such as hydroelectric that have to use bigger installation space, can reduce usage of fossil fuels power generator so less carbon monoxide release. It's an eco-friendly technology since the product input and output do not cause any harm to our environment, and promising technology for solving power crisis to an affordable extent as emergency power backup. Most material in this product using recycled material and low cost. For the concept and impact of engineering solution to sustainability development, it is the same for the economic revival of growth, and the others is same. Revolutionize the method of economic growth, ensure sustainability production, and innovative technology with risk management. So for chapter 8 about the economic costing and business plan. So this is our estimated cost for our project. The standard component cost that involve electric motor, inverter, gear, bearing, chain, battery and fan. So our total is 264 ringgit. So for the custom part, that is base, housing and shaft, we use stainless steel material. So in fabrication process of shaft, we have two alternative manufacturing process. The first forging and second is lathe. So this is the estimated cost for both alternative fabrication process for making shaft. So for labor payment we get this, so the total of we get 4 ringgit and 10 cent per shaft and so on. So after we calculate all the alternative, we got to the total manufacturing cost. For alternative 1 there is 39 ringgit and 60 cent, and for alternative 2 there is 30 ringgit and 40 cent. So alternative 2 is a lot cheaper than alternative 1, so we will use conventional lathe to fabricate the custom component for the Footstep Electric generator, and our total component cost will be 294 ringgit and 40 cent. So this is our project structure. Footstep Electric generator designed by mechanical head. The performance is to generate electricity from human footstep and generate power to certain application. So this is our selling price, weight, estimated lifetime and maintenance.